Hi, this is Paul, Marcus, and Håkon from the Computer Vision course at NTNU. Today we're going to talk about threshold. Thresholding is the simplest form of image segmentation. Thresholding is often used to convert a grayscale image to a binary image, that is, a black and white image. What you do, basically, is choose one shade of gray as your threshold. Then anything darker than that will be black, and anything brighter will be white. Every image consists of a certain amount of pixels, determining the size of the image. Every pixel has certain numerical values, determining the color of the pixel. A grayscale image has 256 grayscale values, where 0 is black and 255 is white. So the natural thing to do when thresholding a black and white picture would be to just cut it in the middle, to put the threshold at 128. Although this would work on some images, as we see on this image, almost every significant detail is gone. We can't even see what the picture is of anymore. Here's another example that just gets worse when using a threshold of 128. The basic global method is a way to compute a better threshold. First, you make an initial guess for the threshold, for instance 128, which is a good place to start. Then, group all the pixels with a grayscale value smaller than this guess into G1, and the rest into G2. Compute the average grayscale value in each of the groups, and then add them and divide by 2 to get the total average. This is your new guess for the threshold. Keep repeating steps 1 to 4 until the threshold doesn't change anymore. As we see here, the result is better. The threshold is reduced to 109 instead of 128, but some of the significant details are still missing. Luckily, Nobuyuki Otsu managed to develop a more precise method, now known as Otsu's method. This method assumes that the image contains two classes of pixels, foreground and background, and separates them into classes. The algorithm then tries to minimize the variance within the groups. This is also equivalent to maximizing the variance between the groups. Thus, we want the deviation in each class to be as small as possible, and the classes to be as far away from each other as possible. The algorithm works the following way. Step 1. Compute the probabilities for each gray level. If an image of size 100 has 3 pixels with a gray level 2, then the probability for the level 2 is 3%. After setting the initial weights and means, we go through all the values on the grayscale and try out a new threshold, iteratively. Go from 0 to 255. For each new threshold, update the weights for the calculation of the variance. The weights is just the sum of all probabilities leading up to the threshold for the first class, and the sum of the rest in the second class. Also update the weights corresponding to the variance between the classes, which is just the class mean. Square the difference between the class means and multiply it by the class weights to get the variance between the classes, and store the variance alongside the threshold you are investigating. When finished going through all the possible thresholds, choose the threshold with the largest variance between the classes. Now we see the threshold has reduced even further to 87. This is clearly a better value for our use, and the picture is more or less replicated, or as replicated it can get with only black and white.
However, Otsu's method has some drawbacks. One of them is that it doesn't work well on pictures with noise, as you can see here. The picture to the left has a rather high degree of salt and pepper noise, but the content of the image is still easy to recognize for us, but Otsu's method fails.
One might now ask the question what image thresholding is useful for. Image thresholding finds application in a variety of fields within computer vision. In the picture on the left, you see rat basophilic leukemia cells under a microscope, although it is very hard to distinguish the cells from the dark background. With the help of Otsu's algorithm, the cells have been highlighted. This is it for this video about thresholding. You have seen how useful it can be and how to find an appropriate value for the threshold depending on the image. We hope you found it useful.